we're good.
Okay. All right. Okay, so we can move, we can shift around basically any function. Okay. I'm gonna just use one that is pretty simple, that you know the function already. Let's just do a parabola, which is f of x equals x squared. No, this is just my few notes that I said I was going to write that wouldn't take long, okay? F of x equals x squared. All right, now, I just want to look at what all the different transformations they could do to this. All right, we know this to be our parent function. It's just a parabola where the vertex of the parabola is right at 0, 0. So we've got our x-axis, our y-axis, right? And we know that vertex at the bottom of the parabola is right there at the origin. All right, so let's say they want you to draw the graph of f of x, okay, equals negative x squared.
Oh no.
All right. What happens if they put that negative sign in the front? Okay, it is going to flip, or they might say the word reflect, which is the more official word than flip, over the x axis. All right, I will tell you that I believe on your paper you will actually see this written as like this. They'll just say negative f of x. They'll just put the, it's the same thing. They're still just putting the minus sign in the front to tell you it is going to reflect over the x-axis. All right, now how do you get a flip or a reflection over the y-axis? Where would the negative sign have to go?
Chicken nugget.
What?
In the parentheses,
It would be in the parentheses, correct. Okay, written like this, that would look like f of negative x, right? That minus sign, instead of being in the very front, is actually paired up with the x in the parentheses. All right, written out in the actual equation, it would still have the minus x in front, but they would make sure to close it in parentheses before they put the squared, so that you knew it went only with the x, okay? And that would be a reflection over the y-axis. Okay, all right, another type of transformation they can do is they can put a number in the front, like 3f of x. Okay, like 3f of x. All right, written with this particular function, that would look like 3x squared. All right, what does that do to the graph when you're basically multiplying times a bigger number in the front? Yeah, vertical stretch. Is that what you were going to say, Tuber?
Yeah.
Yeah, vertical stretch. Okay, it is going to stretch out the parabola. It doesn't move the vertex, the 0, 0, but the points here would end up being higher up, and the graph would actually look a little bit narrower because of it. Okay, it's a vertical stretch. All right, now the only difference is sometimes instead of a whole number greater than 1 on the front, they could use a fraction or a decimal, usually a fraction though. They're like 1/2 f of x. That has it does have the opposite effect. Instead of kind of stretching it out vertically, you would say that it would sort of compress or compact it, actually push it down and make it a little bit wider looking. Okay, they would call that a vertical compression.
Squeaky desks. good one.
All right, excellent. Let's continue.
No.
Halfway there.
Friday.
All right, so we can also, instead of having that number in the very, very front, right, you could have it inside the X.
Oh,
All right, so it's f of 3x. I'm using the same numbers, but showing you that it is now paired up with the x.
this changes everything.
That changes everything. All right, actually not a whole lot, but so, all right, it would also be paired with the x, you know, in the parentheses like that when it's actually written as part of the function filled in. Okay, this affects it horizontally. All right, remember everything that happens horizontally, it's basically backwards of how it was when it was vertical. You're gonna hold it now? Is this better? You rock. And that's in the video. EJ rocks. Okay. Filming for you guys. All right. Okay, so this is going to be a horizontal. It's actually going to these are, yeah, it's going to compress it. Yeah, it's gonna compress it. Yes. No, I just said it's gonna be the opposite, and then I was confusing myself already. Okay, it is going to be a horizontal compression. Yes, meaning it is going to sandwich in, you know, this way. So it kind of looks like what happens when you do a vertical stretch, right? It gets narrower and compresses. All right, and then of course you can have f of 1/2 x in the parentheses if it is a fraction instead of a bigger number. All right, and that would be your horizontal stretch. All right, and I think those compression and the stretch ones are probably the hardest ones of these to think about. All right, what are the easiest ones?
Plus.
Yeah, the shifts, right? When you're just sliding the whole graph up or down or to the left or right, right? All right, so we will look at the translations or the slides, right? Next, so this would be written something like this: f of x plus or minus, let's do 7. Perfect. All right, okay, if it is hanging off the end like that, all right, what does that tell you about how it is going to shift?
Up or down.
Yes, it is going to shift, all right, either up or down. So x squared plus or minus 7. Okay, it is a translation or a shift vertically up or down. Now, I wrote plus or minus just to compact this into one line instead of writing 2 separate lines. But if it is plus, it is going to go up. If it is minus, it is going to go down. That about sums it up. All right, now, where would a plus or minus 7 go if we were going to shift something to the left or right? In the parentheses. So it would say f of x plus or minus 7 in the parentheses and not just hanging off the very end. And it is reversed. Yes, remember things in the parentheses happen in reverse of the way you think that they normally would. Right, so this would be like x plus or minus 7 in the parentheses squared. Okay, it is a horizontal shift. All right, meaning it would go right or left. Okay, so if it is a plus sign, which direction is it going to go? It goes to the left. Alright, this is the one that gets somewhat confusing, but basically once you get it down, you kind of, it stays with you. It's like riding a bike.
No, it's not.
Alright, it'll shift left or right.
Learning this is a lot less painful than learning to ride a bike.
Yeah, oh true, no falling.
Yeah.
Okay, maybe some failing, but no falling.
No problem.
Yes, yes. Alright, so keep those out on your desk, or if you wrote it on your activity, then that's awesome. Let's take a look at the in-class activity for a second. Alright, let me just show you how this works, and then it should be pretty easy from there. For this entire activity, you know how we were using x squared, just the parabola, as my example graph? This is going to be the graph you're using throughout the whole activity. That's what's on the first page at the top.
That's like the Grinch.
Yeah, this is the function, the graph of f. That's your function, okay? They've given you, this doesn't look like a table. They said this is your table for f. If you want to write it as a table, you can do that. It might just make more sense that way. Remember, your x value is what they put in the parentheses, so they're basically saying if x is -2, then there's a point at +1. Right? If there's a, if x is -1, there's a point at -1. If you want to write it in table form, this is how we usually look at it. 0, 2, you have the point 1, 1, 2, 3, and 3, 0. Okay? All they want you to do down below that, okay, using this function, they want you now to fill out the table and graph f of x plus 2, all right? This is f of x, all right? What did they do to the graph by making it f of x plus 2?
Left 2.
We're going to shift it to the left 2, okay? Now, will that change? Let's see, did they already change the x values then?
They did.
Yeah.
Yes.
Oh, they already did change the x values.
So why is
You
it
just-
different?
Yeah, the y values shouldn't change, right? If you shift something left or right, the y numbers don't change. So they should be the same on this table as they were up here. So it would be 1, -1, 2,
So it's graph this guy.
1, 3, and 0. Okay, and then you just draw the new graph. It should look exactly like this one. It's just every point is now shifted over to the left too. Does that make sense? Yes, so instead of being at 3, 0, this one's going to be at 1, 0. This one will be right here. All right, basically plot the points from your table. All right, then you have one.
Easy peasy.
Yeah, it shouldn't be too hard.
Oh, it's like the same thing for all of these.
It is. They're just moving them a different way.
This is better than nothing, so.
It's better. 1 minus 2 minus 3, -1. -4. 1. Okay, so once you connect it, unless you plotted something wrong, it should be the same shape as your original function. Questions? Okay, so what you can do is you can work on this with a small group of